Okay, so what we're going to find now are the points of intersection between these two equations, or these two lines. First, we have a parabola, y equals x squared, and the second line is a linear equation, y equals half x plus 2. To find the points of intersection, which are the points at which the graphs cross, we need to solve the graphs simultaneously, solve the equations simultaneously. So, y equals x squared, we'll call that equation 1, and y equals half x plus 2, that's equation 2. Now, they're both equal to y, so we can say 1 equal to 2, which means we can set them equal to each other, because they're both equal to y, so they equal each other. Okay, I can see how I've got an x squared, I can also see I've got an x with a coefficient, and I've also got a constant or a number on its own, which means that's the building blocks for a quadratic. So what I'm going to do is I'm going to get a quadratic in the form ax squared, bx, and c. Alright? So I'll leave ax squared on the left-hand side, so it stays positive. I'll then take a half x from both sides, and take 2 from both sides and set it equal to 0. Okay. Alright. So a is equal to 1, b is equal to a negative half, and c is equal to negative 2. I'm going to set these into the equation, quadratic equation, which is minus b plus or minus the square root of b squared minus 4ac, all over 2a. Put in my values. Be very careful here. The formula says minus b, but my b value is also a negative, so I end up with minus a half, which I know is going to become a positive. Be very careful with that. Minus a half all squared, minus 4 lots of 1 times negative 2. All over 2 times 1. So that gives me a half plus or minus the square root of a quarter plus 8. Because minus 4 times 1 is minus 4, times by minus 2 is negative 8. All over 2. I'm going to put that into my calculator. So I have 0.5 plus the root of 0.25 plus 8. Make sure that's all under the square root, all divided by 2. So x equals 1.7 to 1 dp. X equals, so remember it's plus and minus, there's two solutions. Negative 1.2 to 1 dp. So you may think at this point you've got your answer. Actually, that is not enough, because all we have are two x values. And if you remember at the beginning, we were looking for points of intersection, which are effectively two coordinate points. Well, all I've got is the x component of those two coordinate points. I've got this x and that x. I don't have the y to go with it. So what I need to do is take these x values. I said x was 1.7 and x was negative 1.2. And I need to sub them in to either equation 1 or equation 2, whichever you think is easier. I'm going to go with equation 1. So y equals x squared. Well, in this case, x is 1.7. So 1.7 squared, which calculator. Y equals 2.89. So that means one of my coordinate points, or points of intersection, is where x is 1.7 and y is 2.89. Okay, let's go for the next one. Again, sub it into one of the equations. I've gone for y equals x squared. That means y is equal to negative 1.2 squared. So y is equal to 1.44. So my second coordinate point is where x is negative 1.2 and y is 1.44. And if we just think about the position of these two coordinates and compare them to our diagram to begin with, it fits, it makes sense. We've got a negative value for x there, which means we've come back on the x value and we've gone up on y. So these are our 2 points of intersection.